Hello and welcome to your first instructional physics class, and of course I'm saying instructional because this is technically the second class, but we're actually going to see one of our first exercises. I'm Mr. Marcus. Welcome again to your summer course. Today we're going to talk about section 1.2, which is dimensions or measurements in experiments, and we talk a little bit about unit analysis. So what is unit analysis? What do we do? Well, most of this information you can find in your textbook if you read from pages 10 to 15. But I am going to give you a little heads up of what dimensional analysis is and what the SI system is. So the SI system is basically a system that was developed in around the late 60s, more or less, so that scientists could have a universal language of units. Although units have existed far longer, it was the SI unit that basically, the SI system that basically took everything and kind of put it in perspective for scientists to use. And on page, I believe it's on page 12 of your textbook, you actually have a table that gives you all the prefixes and all the abbreviations and all the values of the units. So what I'm actually going to do is just go straight into the application of it, and at the end of this video you're going to have the practice problems that you're going to work on. Okay, so what we're going to do is we're going to do a little bit of unit analysis, or dimensional analysis as it's also known, and we are going to convert one unit to another. Again, there are a lot of units in that table, and besides there are also other units that you can look on online. So it says a scanning tunneling microscope, or STM microscope, has a magnifying ability of 100 million and can distinguish between two objects that are separated by only 3 times 10 to the power of negative 10 meters, or about 100 of an atom, or 100 the diameter of an atom. Express 3 times 10 to the power of negative 10 meters into nanometers and picometers. So pico and nano are prefixes of the unit meters. Meters is used mainly to determine length. So what we're doing is we're using meters as our base unit, which is length, but we have prefixes, in this case pico and nano. And it's actually on page 12 of your textbook that you can see the table along with the prefixes. So what I did was, we have to understand that when we're going from one unit to another, or when we're undergoing dimensional analysis, we need to express them as a ratio. And a ratio is a fraction. It's like saying 1/3 is equal to 3/1, right? Or a simpler way, a ratio is just a simplified fraction. So what I'm trying to say is a ratio is 1/3, right? The numerator represents a unit, the denominator represents another unit. And when we're talking specifically about measurements, the ratios are different. For example, in measurement we can say 1 foot equals 12 inches, or 12 inches equals 1 foot. 1 feet equals 12 inches, or 1 foot equals 12 inches, however you want to say. But the idea is for you to understand that dimensional analysis is a ratio. It's just that the ratios that we're going to see are slightly different than the ratios that we've seen prior. So for example, one thing that is very important is if I want to express this 3 meters, or 3 times 10 to the power of negative 10 meters, which is written in scientific notation, and scientific notation always has the times 10 because it tells us or helps us distinguish when a number is extremely large or extremely small. Anyway, 3 times 10 to the power of 10 meters, and I want to convert that into nanometers. So whenever we're looking, or whenever we're working with dimensional analysis, we want to go from one unit to another. What we want to do is actually cancel them out. Now, and I'm going to step out of camera just to make sure that nothing is going wrong with the picture. Maybe zoom in a little bit. Okay, so when we're working with dimensional analysis and we want to go from one unit to another, we have to cancel it out. Now, one thing that you have to understand is that meters cannot cancel out with any other unit that is meters, which brings us to a ratio. A ratio says that 1 nanometer is approximately 10, or 1 times 10 to the power of negative 9 meters. Okay? So in 1 nanometer, I have 10 to the power of negative 9 meters. Or I can also say the opposite, which is 1 times 10 to the negative 9 meters equals 1 nanometer. Now it's the same ratio, it's just that I expressed it in different ways, but they mean the same thing, regardless. Now how do I know which one I'm going to use? Well, you want to look at your ratios and you want to look for the one ratio that cancels out the meters, or in other words, where meters is at the bottom. Or another way of saying it is if you're going from a larger unit to a smaller unit, you divide. So what cancels meters with meters? Well, that would be meters. And which one of these two ratios has meters as my denominators? And it would be the first one, which says that 1 nanometer equals 10 to the negative 9 meters. So I'm actually going to just write 1 as my numerator and 1 times 10 to the power of negative 9 as my denominator. Now what's going to happen is that the units cancel out, so meters is actually going to cancel out with meters. And what I'm going to do is just, simple math, okay? So you're going to multiply 3 times 10 to the power of negative 10 times 1, which is going to be 3 times 10 to the power of negative 10 over 1 times 10 to the power of negative 9. And of course the unit is nanometers because the meters canceled out. So now it's basic math. You're going to divide 3, or 3.0, which is the same thing, by 1, which equals 3. And they both have exponents with the same base, so times 10. And if you remember your algebra, whenever you are dividing exponents with the same base, you subtract them. So this is actually going to be negative 10 minus negative 9 nanometers. And of course, negative 10 minus negative 9 is negative 1. So my final answer is actually 3 times 10 to the power of negative 1 nanometers. Or, if you divide that, 0.3 nanometers. Either one of them is correct, okay? So we already did the first one where we convert it to nanometers. So again, I'm going to step out of camera, give you the opportunity to observe what I did. Real quick, if you observe, all I did was and I'm going to zoom in real quick. What I did, I'm going to lift up the camera. What I did is I just took the 3 times 10 to the power of negative 10, and I used the ratio in which meters is my denominator, and I substituted that. So the next step was to multiply 3 times 10 to the power of 10 times 1 over 1 times 10 to the power of negative 9, and of course the meter units canceled out. I divided 3 by 1, which is 3 to the power of 10. Now whenever I'm dividing an exponent that has the same base, I subtract them, so that would be 3 times 10 to the power of negative 10 minus negative 9, which equals 3 times 10 to the power of negative 1 nanometers, or 0.30 nanometers, or 0.3 nanometers. Okay, so let me adjust the camera. I'm going to zoom out now. And I'm actually going to go ahead and do the last exercise. The last exercise is to convert 3 times 10 to the power of negative 10 meters to picometers. So let me go ahead and erase this. And then I'm going to step out of camera and make sure that everything is in focus. So now I'm going from 3.0, or 3, which is the same thing, times 10 to the power of negative 10 meters, but I'm going to go to picometers. So that's abbreviated PN. Now my ratio says that 1 picometer is 10 to the power, or 1 times 10 to the power of negative 12 meters, or 1 times 10 to the power of negative 12 meters, is 1 picometer. So again, if I'm going from a larger unit, which is meter, because technically there's a negative there. So if I'm going from a larger unit, which is 3 times 10 to the power of negative 10 meters, to a smaller unit, which is picometers, I'm going to divide. Now that's a little bit difficult for you to remember, because sometimes it can be just write the ratios. 1 picometer equals 1 times 10 to the negative 12 meters, or 1 times 10 to the negative 12 meters equals 1 picometer. What you want to do is you want to cancel out your units. So which one of these has meters, or which one of these two ratios lets me cancel meters with meters? And it would be the first one. So we would just simply substitute and say 1 picometer is 1 times 10 to the power of negative 12 meters. And what's going to happen is that meters are going to cancel out with meters. And you're going to multiply 3 times 10 to the power of negative 10 times 1, which is 3 times 10 to the power of negative 10 over 1 times 10 to the power of negative 12, of course, picometers. And then we're just going to execute the division problem. 3 divided by 1 is 3. So that would be 3. Let me actually write it here. So that would be 3 times 10 to the power of negative 10. But because I am subtracting or dividing, exponents with the same base, that means I'm going to subtract my exponent minus negative 12. And that's picometers. And negative 10 minus negative 12 is actually the same thing as saying negative 10 plus 2. So your answer is actually 3 times 10 to the power of 2 picometers. Or 300 picometers, however you guys want to say it. Okay? So I'm going to step out of camera, make sure that everything looks according or appropriate. Let me raise the camera again. Okay? So what I did was I used the ratio in which meters is my denominator, and that way I can cancel out my meters with my meters. So what I did was I have 3 times 10 to the power of negative 10 meters over 1 times 10 to the power of negative 12 meters. After that, what I did was I canceled out my meters with my meters, and I divided through or multiplied 3 times 10 to the power of negative 10 times 1, which is the same number. Then I divided 3 times 10 to the power of negative 10 over 1 times 10 to the power of negative 12. 3 divided by 1 is 3. Whenever I am dividing exponents with the same base, what I do is I subtract the exponents. So negative 10 minus negative 2 is actually positive 2. And my final answer is 3 times 10 to the power of 2 picometers. You can always pause and rewind the video. I'm actually going to zoom out real quick. Okay? So, again, 3 times 10 to the power of negative 10. I chose this ratio because it has meters as my denominator and I can cancel out. So meters cancels out with meters, and I multiply 3 times 10 to the power of negative 10 by 1, and that leaves me with 3 times 10 to the power of negative 10 over 1 times 10 to the power of negative 12, and of course picometers because the meters cancel out. 3 divided by 1 is 3. Whenever I'm dividing exponents with the same base, I subtract them, so that would be negative 10 minus negative 12, which would equal to positive 2. My answer is 3 times 10 to the power of 2 picometers. What you're going to do is once you've seen this video, once you've reviewed this video, once you've seen the read pages 10 through 15 and seen the other supplementary presentation I uploaded along with this, once you've done all that, you're going to go to page 15 of your textbooks and you're going to work on problems 1 through 5. Remember that this week's assignments will be emailed to me on Friday. So this is your favorite physics teacher saying goodbye, stay safe, and I'll see you soon.